Okay, Year 12, I'm just going to go over the question that I said would be difficult. So if you're having trouble with it in class, it's going to be this one here. Question 14. Find the indefinite integral of 3 to the 2x minus 1. Now, before we do that, before I start that question, I'm going to go back and have a look at something we did earlier. So if you watch the other video, or what I want to be able to do is I want to look at how I'm going to, or what I'm going to do here with y equals a number, a constant, a to the x. Now we've already done this. If we look back here to the work I did before, here's y equals 3 to the x. We rewrote it by going x equals log base 3y. We then took the log of both those by change of base. We've got ln y over ln 3. I pulled the 1 over ln 3 out the front, which is still multiplied by ln y. I differentiated with respect to y. So I've got 1 on ln 3 times 1 on y. And because we know that dy dx is a reciprocal of dx dy, I can just turn it upside down, and I replaced y with what we originally said it was, which was 3 to the x, and I got this here, 3x ln 3, or ln 3. So if I'm doing it for this, I know that y dash is going to equal ln a 3 a to the x. Now that's important because what I'm going to do now is I'm going to have a look at integrating a to the x. Now here, remember that integrating is just the reverse of differentiating. It'd be good if we had ln a to the x because the integral is just a to the x. But I don't have a to the x. But that's okay because the integral of a to the x dx, I can do a bit of hokey pokey. If I don't have what I want, and it's a constant, and remember ln a is a constant, I can put the ln a in and I can take the ln a out because it's a constant. It's a number. That gives me 1 on ln a. And now I know the integral of this because I differentiate it. It's just a to the x. So ln a to the x, or 1 over ln a times a to the x plus some constant. So if I were to integrate 3 to the x dx, I would have to do a bit of hokey pokey. I'd have to put an ln 3 in there and a 1 on ln 3 here. And we know because we did this one up here, the integral of 3x ln x, or ln 3x, is, 3 to the x. So it's going to equal 1 on ln 3, 3 to the x plus some constant. So what about our question 14? Find the indefinite integral of 3 to the 2x minus 1. All right, so let's do it over here. 14. I want to find the integral of 3 to the 2x minus 1 dx. Now I'm lucky. Because what is up here is linear, because I'm going to do a substitution. So I'm going to let u equal 2x minus 1. Therefore, du dx equals 2. Therefore, du equals 2 dx, or for those who like to do it this way, 1 on 2 du equals dx. And now I can do some substitution. So what do? I go, well, the integral of 3 to the u. Now, I don't have 2 dx there, but again, I'm going to do some hokey pokey. I'm going to put a 2 dx there, and I'll put 1 on 2 there. I put the 2 in and I took the 2 out. And now I have a half out the front, 3 to the u du. And we just integrated that over here. It's 1 on ln 3, 3 to the u plus c. So 1 on 2, 1 on ln 3 times 3 to the u plus some constant. So 1 on 2 ln 3 times 3, and I'm going to put my substitution back, my 2x minus 1, 2x minus 1 plus my c. And I think that's the answer. I'm just going to check exercise 4.8. I've got the hard copy textbook here, and 4.8, question 14. Yes, they write it as one fraction. We can do that. 3 to the 2x minus 1 over 2 ln 3 plus some constant. Now, the last question isn't that hard. You should be right with that. That's how we integrate a power in the base that isn't e. Remember, e is special. E is special because the integral of e to the x doesn't have that constant. It's just e to the x plus some constant. And that is fantastic. Anyway, have a look at that. If you're having trouble, I hope you struggled with it first, and I'll see you in class tomorrow.